So I'm not sure if I'm going to be able to edit this, so please excuse any shakiness. Also excuse any noise that you might hear in the background. As most of you guys are aware, I do have a 2-year-old and a 7-year-old, soon to be 8-year-old tomorrow. They may be in and out, and I might have to pause this and chop this up a little bit. But what I plan to do is, I plan to be going over some of the courses on Edmentum. I'm just basically going to be going over the ones that have mastery tests. So I've had a lot of questions. I've had a lot of you guys struggling. I'm not going to lie. Some of the things on there, especially the topics that were left for us to cover, which was mainly statistics, is really hard to understand, just point blank. It's even harder to understand whenever you have to teach it to yourself through some tutorials and videos, which in my opinion, to be honest, they're a little bit complicated. So what I've decided to do is these pages actually come directly from the Edmentum website. So they're supposed to go with the topics that have the mastery tests. I will attach these to the links in the emails that I send. Whenever I upload a video, I'll send an email out to you guys and say, today I covered understanding statistics, and here's the link to the video. I plan to upload this to YouTube if everything goes well, crossing my fingers. If not, it might be directly attached to the email, so we will see. But I do know it takes up quite a bit of memory. So it's something that I plan to do through YouTube, because then there's no downloading. All you have to do is watch it. So how can you use these and how these are going to help you? First of all, if there is an exam, a mastery test that you took and you failed it to the point where you'd like to retake it, there's a way to unblock mastery tests whenever they get locked, and that is to go back through the tutorials that should unlock the mastery tests. You have to click back through the whole tutorials. If it doesn't, then you can ask me and I can unlock it. And if you just want to retake it, I can wipe the score out and let you take it again. So now that we'll be using these to hopefully help, if you did score a low score on understanding statistics unit and you would like to go back and do it, just shoot me an email and say, I would like for you to let me retake understanding statistics, and I'll do that. Keep in mind that I don't want to continuously be doing it. So if it does become an issue, I'll cut it off at, you can only retake it once or twice, something like that. So make sure that when you do retake it, it's because you're ready to retake it. Okay. With that being said, this is the Algebra 2 one. So I am starting with the first one that says understanding statistics. So if you are at a computer and you can have like your phone and your computer out, then that's ideal, because you could have this video playing and then you could have the tutorial playing at the same time and you can kind of follow along. So I kind of cheated already, and I already have a key that I have filled out because I watched the tutorials and I got the information from there. These do match up to the tutorials. So what I'm just going to do is I'm just going to explain to you what they are. You can go back and watch the tutorials with this information already filled out, look over it, and then try to take the mastery test. I took the mastery test just using the notes, seeing if that helps. I passed all the mastery tests just using the notes, but there were still a few questions that were a little bit tricky when I was taking them. Just to be honest, they just are. So there's a few questions where they worded were trying to trick you. But anyways, let's get started. Okay, so at about minute 4 is when we're going to start this, and I'll kind of leave that in the description, that at minute 4, if you want to skip through the whole part at front, the explanation, minute 4 is when we're starting. Okay, first thing I'm going to do is they give you a list of vocab words that you're going to use throughout this particular lesson, which is understanding statistics. I do have a printout of all of the terms for the whole statistics unit. You will not use all of them, but I will link that, of course, in there as well. You're free to print these out if you want. If you just want to look at them, then that's okay. Okay, so what is a survey? Again, I have these already printed out, so I will be looking at my sheet to copy these down. Keep in mind that this is the long book definition, so you can always shorten it if you want to. But a survey is a type, this is a pretty long one, so if you write big, it might not fit, a type of observational study that requires a group of people to respond to a set of questions. Okay, I'll leave that there if you want to look at that. So let me move this over a little bit so you can see the full thing. Okay, so very wordy. You should already know what a survey is. Most of you guys know if I say let's take a survey, you know that it's a bunch of people getting something asked to them. You know, it's a questionnaire, things like that. So most of you guys know that. Descriptive statistics is already written in for us. A process of collecting, measuring, and presenting data from a random sample of population. Then we have mean. Most of you guys know what this is. It's just when you take whatever you have, however much data you have, you add it all together and you divide it by the number of data. So again, this is a wordy definition, but that's basically what it is. So mean is the sum, which means to add, of all the values in a data set divided by the total number of data values. Okay, so again, most of you guys know what that is. Inferential statistics, a process for making inferences about population parameters based on data collected from a random sample of population. As we go through, when we use some of these words, I'll kind of break them down more. Again, I'm just going to write down the vocab word right now in case you just need to go back to use it. So this is a process for making inferences about population parameters based on data collected from a random sample of the population. Okay, so again, these words are in that packet of vocab words that I will also link. So again, if I go too fast, if you can't see how I write it, it's in there. You just have to look for it. It's in ABC order. You look for the word and you can write it down. Also, this is a video that you can pause and stop, write it down if you need to. Okay. The next word is population. In statistics, the overall group from which the data is sampled. So in layman's terms, all that is saying is population is what you are studying. So if you're studying a classroom, it's the students in the classroom. If you're studying a supermarket, it's the people inside the supermarket. So again, it's just whatever you're studying and collecting data on. Okay, sample. So a sample, again, this is going to be wordy, but I'll explain what it is a subset of a population that is analyzed. Okay, so, and this again will get explained in the tutorial and in these worksheets, but basically what this is saying is a population sometimes is quite large and you cannot ideally survey everyone in the population. So for example, if there was a survey done on all of SCHS, it's a lot of people, a lot of students, but we might say, okay, we're only going to ask the juniors a question, we're only going to ask the sophomores this question. Now you no longer have the whole school, but just a subset of it, which again would be a sample. Okay, point estimation. Again, this is a large process. The process of using statistics to make inferences about population parameters. Okay, so this is again basically just saying that there is a process in which you come to conclusions into the data that you're analyzing. It's not just random. When you come to a conclusion, there's a way to kind of weed it out. We'll talk more about that, but that kind of talks about bias. So if you say, I'm only going to ask the juniors this question, and you ask what percent of the SCHS drives, well, juniors, most of them can drive. But if you asked only the freshmen, that would be a completely different situation. So again, you have to be able to make it where it's unbiased, which we'll talk about more. Okay, sample statistics is a measurement of a sample characteristic. Okay, so basically we're going to measure something that is a characteristic of the sample. So how long it takes them to do something, you know, something like that. Again, we'll talk more about it. And I do want to mention, before I forget, the links that I should, or the PDFs that I should link into the emails should allow you to type into these little boxes that are blank, and you can actually print them out typed up if you don't want to write it, if you have bad handwriting or anything like that. So that is something, an option that you have. Okay, sample proportion is the proportion of members of a sample that share a certain characteristic. Okay, and again, we'll talk more about this, but characteristics really just depend on what you're talking about. You know, if it's the driving situation example that I did, it's like how many people are of 16 and carry a license, more than likely they're going to drive, versus freshmen who don't have a license and they can't drive. Obviously there's other factors. You might have a license, you might be able to drive, but you can't drive, you know, you don't have a car, you know, something like that. Okay, population parameters, a measurement of a population characteristic. So again, a measurement of the population characteristic. So this is a bigger chunk, because one above was a sample characteristic. That was a smaller chunk of the population. Bias. So we talked about this a little bit. It's a problem that presents itself when a sample is selected to analyze fails to truly represent the population. So again, if you're taking a survey, but the fact that you're leaving out or including something that is going to make this survey biased, which would mean the answers would be different depending on how you would select the people or the information that you're gathering, then it's considered biased, and then you can't really truly rely on that data. We see that a lot. So you'll hear people just chug out numbers, but to be honest, those numbers mean nothing if you don't know that they're not based on true analyzed data that was unbiased. So again, I could interview just 3 people and say, like, do you enjoy school? I could go to 3 people and just ask that, and the 3 people say yes. That does not represent the whole school, because that was only 3 people. So not only does the population have to be large enough, also it has to be unbiased. What if those 3 people were teachers? More than likely they're going to say yes, they enjoy school. You know, again, so those are certain things which we'll talk about more. Randomization, again, seems a little bit complicated. I'll write it all out. It's probably the longest one of the definitions that we have, but then I'll explain it a little bit. So it's the process of choosing a random sample in which each member of the population has an equal probability of being selected for a sample. Okay, so randomization, again, has to do with what we were just kind of talking about. Basically, it's talking a little bit about not being unbiased and the way you choose people. So if I ask the first 3 people that walk into my class, that's not a true randomization because I'm only asking the first 3 people. I have 157 kids. I only asked the first 3 people that walked into my classroom. That's not enough people, and I'm only asking a certain percent of kids when I see them throughout the day. Maybe I ask on a Monday. I don't even see the kids that I'm supposed to see on Tuesdays and Thursdays that day, so I wouldn't even get a fair representation. So randomization is the process of choosing it and making it fair to where everybody has an opportunity. What if I asked the first 10 people in each class, my Monday classes and my Tuesday classes? Now that's a better representation. That gets more of my class as a whole. So again, those types of things makes it more fair. Okay, so now we're going to keep going. Again, some of these words might still be question marks in your head, but as we use them, hopefully they'll clear up a little bit. Okay, so the objective. You will have an objective in each of the tutorials that you're given, and they'll do them pretty quickly. I had to pause the tutorial so I could write this down, so you might have to as well. In this lesson, you will identify and explain, and this came directly from the tutorial, the purpose and structure of statistics and random sampling and make inferences from sample results. Okay, so again, all of that came from the website directly, so I don't think you can see it all, and I can't really zoom out more. There's no more for my phone to go up, but I'll read it again. So it's identify and explain the purpose and structure of, so there's that part right there, if you want to pause it and be able to get that. Then the next part is of statistics and random sampling and make inferences from sample results. Okay, so this next part has a few blanks that we need to fill in. So statistical concepts. Statistics is split into 2 branches. The first branch is called descriptive statistics, which again is at the top, but we're going to explain it a little bit more here. Okay, what this is all about, it's collecting data, presenting the data in charts and graphs, and calculating the statistics that describe it. So it's the whole process of getting the data, putting it into a pie chart, putting it into a histogram, putting it into all of that. That is descriptive statistics. Okay, inferential statistics deciding what we found through descriptive statistics tells us about the situation. Okay, so basically the first one is collecting all of the data, and the second one is coming to a conclusion from the data. So I'm gonna write that right above it. So collecting data and conclusion from data. Okay, so it's mainly the big differences between them. Okay, so we are going to move a little bit faster now. You don't have as much writing to do anymore, and I'll go ahead and tell you that I did skip all of the hands-on activities that were done in the tutorial. There were printouts for it, which I have somewhere around here, but I decided not to use them. This is what they look like on your screen. So it was like it was a lesson activity, making inferences. It had directions activity, and then I've got some answers here that I wrote. But to be honest, it doesn't do any good to have them on paper and pencil. Those are interactive ones that you need to do online. Okay, so what we're gonna do now is keep going. So the next page looks like this up at the top, and now we're gonna basically talk about population versus sample, which we talked about a little bit already. And again, there's a lot less that we have to write now, so we will be going a little bit faster. Just to look at the picture before we go to the words. So population is the dark, bold line, and then a sample is taking a part of that dark, bold circle and pulling out a sample from it. So it's the whole population chunked into something is your sample. So that's what the picture is showing. Okay, so in words, let's fill this out. Okay, so a population is the entire group. Okay, so population, entire group of objects, people, and so on. So whatever it is that you're collecting data on of interest in a given situation. It's really what we want to know about what we study in statistics. However, we can't look at the whole population. It's just too big in most cases. So instead, we collect and study a subset of the population. That subset is called a sample. Okay, so sample is a subset of the population. So right there in very small lines, we could have answered what population was before on that other page where we had to fill it in. Population is the entire group. Sample is a subset of that population, so a subset of the group. Okay, it's important to remember that population is what we're ultimately interested in, but the sample is the data that we collect, examine, and measure. Okay, just to word this, in other words, this is saying it's important to remember that our goal is to figure out what the whole population is really trying to get to, but we only take a chunk of it to come up with the results that we predict are true for the whole population. So, to give you an example with people, mostly we think population is people, but sometimes population is an object. We're going to do an object example here in a second, but to do an example with people. So if I said, I want to know how many people enjoy school, and I'm going to ask a subset of the school. I could ask just my classroom. That's not a big enough representation of the whole school. So I would have to think of a different way to ask it. So I might say, I'm going to go to every English class and ask 10 random students in every English class for a period of 2 days. That way I get the Monday and the Tuesday classes. And I'm going to do that to, if we have, let's say, 20 teachers that teach English, I'm going to do it to about 10. So therefore I get a good variety, and I'm going to make sure and I ask at least 2 teachers, minimum of 2 teachers per grade. So I get freshman English teachers, sophomore English teachers, and so forth. So now I have an idea of the students telling me yes or no, I enjoy school. At the end, I'm going to say 67% of the population enjoys school. I didn't ask 67% of the population. They didn't answer yes. 67% didn't answer yes. A smaller chunk did, but I predicted that because I asked a small chunk of people. 67% of them did. Therefore, I think 67 of the population, is going to have that answer. Okay. So now we're going to look at an actual example that they give in Edmentum. Suppose you're a quality control manager for a factory producing compact fluorescent lamps, CFLs, and that's what they will be called from this point forward. And it's your job to decide whether a batch of CFLs should be shipped. These are your criteria for allowing the shipment of the batch. So it's between these two, and they both must happen for you to be able to ship the bulbs. And if either one of these is not true, then you can't ship the bulbs. The average lifespan of the CFLs in the batch must be greater than 10,000 hours, and the number of defective CFLs must be less than 1%, the total number of CFLs in the batch. A defective CFL is one with a span of 0. Okay, you have all this data here, and again, you're probably either looking at it in front of you if you printed it out, or on your computer or phone or wherever if you have it. If you're looking at Edmentum, it'll be on there as well. Let's say you look at a random sample of 150 CFLs from the batch. The lifespan is 150 CFLs in your sample shown below. So these are 150 numbers. Keep in mind that a CFL has a lifespan of 0 will be defective. So what I'm going to do is I'm going to go through, and anywhere I see 0, I'm going to highlight it because that is a defective one. So there's 1, 2, 3, I think that is it. Okay, so I found my defective ones. So now we're going to move on to the next page, because fortunately you do not have to add these. They've done it for you. But if you did not have them already done, then you'd have to do that part. Okay, so I'm going to set this aside. And here is the next page. Okay, first determine the average lifespan of the CFLs in your sample. To find the average lifespan, you're going to add, which I just said we don't have to do because it's already been given to us, you'll see in a second, all of the lifespans, and then divide by 150 because there was 150 bulbs. If you remember, this is the mean. This is how you find the mean, which is the number of CFLs in the sample. It turns out that the sum of the lifespans is, so here is that sum. We don't have to do it because they've already done it for us. So the average lifespan is that number divided by 150. And if you put it in your calculator, you should get exactly 10,146 hours. Okay, the sample is the mean. Okay, so this is important because sometimes you use certain calculators when they give you this symbol right here. It stands for mean. It's an X with a little line on top. Okay, and this is the average. Okay, the lifespan of the CFLs in the sample, because the sample mean is being used to estimate the average lifespan of the CFLs in the batch. The first criteria for the shipment has been met. So remember, we have to have both of them met. So far, the average lifespan is over 10,000, so that's good. If you remember, the other thing was there couldn't be more than 1% defective, so that's what we're about to find. If you remember, I highlighted 3 prior to this that were defective. Okay, next determine the proportion of defective CFLs in the sample. The table shown below the table showed before showed 3 lifespans of 0. In other words, there were 3 defective CFLs in the sample. To find the proportion of defective CFLs, you're going to divide the number of defective CFLs by the total. So there was 3 defective. So this is defective. This is total. Okay, you get this number to come out. Now remember, this is not percent, this is in decimal form. To change it to a percent, you move your decimal over twice. So this becomes 2%. Okay, the proportion of defective CFLs in the sample is 0.02 or 2%. If you remember, the criteria was it had to be over 10,000 lifespan and it couldn't be more than 1% defective. This proportion is called the sample proportion. Because this is not the population proportion, this is a sample that we took and it has a proportion of 2% defective. And it is denoted with the symbol P with a little house top because the sample proportion is being used to estimate the proportion of defective CFLs in the entire batch. The second criteria for shipping the batch has not been met, therefore you shouldn't ship the batch. Okay, the actual average lifespan of all the CFLs in the batch and the actual proportion of defective CFLs in the entire batch are called population parameters. Okay, so all of the lifespans, all of the defective would be the population parameters, but we're not testing all of the population because there's an enormous amount. We only took a sample. Since we're using a sample mean and the sample proportion to estimate population parameters, the sample mean and sample proportion are point estimates. So this is just saying we're using the sample data to estimate into our population data. Okay, now let's talk about random samples. A sample chosen from a population without any bias, and we talked about what bias was already, is called a random sample. The process of choosing a random sample is called randomization. In this process, each member of the population has an equal probability of being selected for the sample. So I gave the example before of if I only ask my Monday classes a question, one, my class does not represent the whole school, and I'm only asking my Monday classes. I'm not even representing my Monday and Tuesday classes, so I'm only getting about half of my students in the data if I were to collect something like that. So again, whatever you present, whatever data you collect needs to have an equal opportunity for everyone. Okay, move on to the next page. Okay, so this is actually very simple. So what is randomization? What does it help do? It helps avoid bias. Randomization protects against unknown factors. You never know what could happen, what could influence or not influence your data, but having randomization helps try to control that. And randomization allows us to draw inferences about a population through sample. Again, that's just making conclusions that if I chose the sample correctly, then I can now predict what the whole population would act. Okay, randomization, and then this is basically repeating what we just wrote. So randomization serves three main purposes, and then these are the important things for randomization. It avoids bias, we just wrote that. In a sample is biased when the reason to believe that it doesn't accurately represent the population, which we talked about already. Randomization protects the sample from unknown factors that may affect the members of the population that are selected for this sample. Okay, so once we have randomization happen and your data is collected and everything is good, then you can now use that data to make inferences. Okay, so what are inferences? Again, I just said it before, it's just drawing conclusions from the statistics that we've taken. Okay, now that we're familiar with the characteristics of a random sample, let's look at what needs to be in place for a statistic of a sample to accurately approximate a parameter. These criteria must be met for a statistic to be a point estimate. Okay, and they will ask this again. I got it asked on the mastery test, but it was asked in a different way. It was like asking a question and presented an example like, Susie gathered this much information, blah, blah, blah. Which of the following is true? And one of the examples they gave, they didn't ask enough people. So it was not enough information could be gathered, So again, it's all depending on the question and what's presented, but just, keep that in mind. Okay. So the sample size must be large enough. That is very important. So those are the things you need to keep in mind when it's asking, can this data happen? To accurately represent the population. Okay, and the sample statistic must be unbiased. Okay, so what is bias? What is an example of bias that we could use? To be honest, there's several, but for example, if I were to be a principal and I'm going around and asking the teachers, do you enjoy teaching here? And I'm going to take and gather that data. Well, with him or her being my principal, then I'm inclined to want to answer a certain way. That makes the data bias. Now, if it was someone random asking it, who has no ties to the school, I'd probably answer more honestly. Now, of course, I love the school and I love STHS, but I'm just saying as an example. But yeah, so something like that, asking something where you're going to basically force an answer out is considered bias. So again, that's important. Okay, let's consider how these principles apply to the examples of testing CFLs. Remember, CFLs were those light bulbs that we had. Okay, if you were to take another random sample of 150 CFLs from the same batch, it almost certainly would not produce the same average lifespan. Because remember, we are testing a sample and we gather 150, we test those. It's not going to produce the same numbers that were on that chart before because it's 150 random, other bulbs, so it's not going to produce the same number. Also, it likely wouldn't produce the same proportion of defective CFLs. This is because the sample is just a subset, just explained, of the population, and the subset changes with each sample taken. Okay, so I want to just kind of mention that the subset changes. So it's not set in stone when you take data that everyone will answer or a bulb will act the same way over and over again. Human nature tends to say that things will change. While it's not possible to eliminate the variability of samples, it is possible to reduce the variability by increasing the sample size. In other words, if the sample size had been 500 CFLs instead of 150, the difference between the samples would be smaller, and the point estimates would be better approximations of the population parameters. Okay, so all this is saying is instead of taking like another 150 and another 150, they're never going to add up to the same. But if I were to increase it to, let's say, 500, like it says there, now the closer it gets to that sample subset that we took of 150, then we know how true that subset was. So again, hiring the amount of people you ask or the amount of things that you test is going to help instead of just keeping the same amount. Okay, and then lastly, finally, if our sample size is large and we've carefully randomized our selection, we can get point estimates that closely approximate the population parameters. When our sample statistics can be used as point estimates of a population, we use the statistics to make inferences about the population. Okay, so here is the summary. Why is it important to take appropriate measures to ensure that a sample accurately represents the population before using statistics to make inferences about and assertions about the population? So you're going to write this in your own words if you want. It's not something that they ask. It's just seeing if you truly understand the lesson. Basically, in my own words, to say a population must be large enough. So it must be large enough, and I'm just going to shorthand it. So it must be large enough, and also the population must be, population selection, I guess is what it should be, must be unbiased. Okay, so those things must happen. If that does happen, then you can truly get data and inferences, which is just conclusions about your data. But if any of these two things is not true, then what you're actually spitting out, those numbers and those inferences that you're making, are not necessarily true. So that's something we have to be aware of, especially like right now with the whole COVID situation, coronavirus going around. We have a lot of numbers kind of going into place and being thrown out. Always check the source, always check the data. You know, cdc.org is a great place to check. Tennessee.gov is a great place to check. But just going on random websites where people are saying there's this many, there's this, and there's this, you don't necessarily know if the data that they're collecting is unbiased. You don't know if the data they're collecting is large enough. So you always want to go to trustworthy sites, you know, things like that. Just kind of keep that in mind, make you feel a little bit better, hopefully, about the situation. Okay. So lastly that I'm going to talk about is how you should use this video to help you with Edmentum. So what you should do, my advice is, I would have watched this video, taken the notes, now have the notes in front of you, and maybe watch the tutorial again. Now, if you think you truly understood what I just said, you don't need to watch the tutorial again, then you can go straight to the mastery test, as long as it's unlocked. So if you haven't seen the tutorial after seeing this video and filling out the information on the papers and having them in front of you, then I would go to the tutorial, and then you no longer have to write. You can just kind of see how everything flows, because everything that I've answered is actually in the tutorial. And all the blanks and everything that I filled in are coming from the tutorial. I would literally watch the tutorial, paused it, wrote a few things, and so forth. So in the future, when I send another video out, I might still just send the PDFs attached to the email. If you feel like you could follow along without having to watch my video, that would be fine. You don't have to watch my video. This is just to help you if you need it. So right now, my suggestion is, if you did not pass with at least a 70, the mastery test for this section, I would say email me and say I would like to retake it. Use this to try to retake it. Hopefully you understand it a little bit more. And then after this, in a couple of days, hopefully Friday, maybe Saturday, I'll be able to upload the next lesson. If you haven't known, we were extended to April 24th to be out, so we have more time to be on Edmentum. I'm not adding on to the courses, but I've had a lot of people complain about how difficult they were, so now you have more time, and I'll be sending out these videos to complete them. Again, I just suggest one mastery test to be done per day. That's all that I ask. I don't think more than that should be needed. It's a lot. You have other classes, and to be honest, statistics is hard. So if you can do one mastery test a day, get it to at least a 70, even better would be, 80, 90, 100%, but get those done. And then after that, you can relax. Maybe the next day or the following day, try another one. Try to get all of them done by April 24th. Also, when I get done doing the videos for these, I'll move on to the review packets that were given out before, but that will not be until I cover all the Edmentum videos. Okay, so again, make sure that you email me with any questions, and I will see you guys soon. Well, talk to you guys soon.